the end of the lesson, so it got a little bit rushed. So this time we're saying this is 10 millimeters, yes? 10 millimeters. This is 1 centimeter squared. I definitely remember saying this last lesson. 1 centimeter squared is 100 millimeters squared. Remember I wrote that as 1 centimeter squared equals 10 squared millimeters squared. Yes, remember that? Now, just in case any of you are a little bit confused, you need to make sure that you are aware that that is the unit, okay? The unit is squared, okay? So it's a centimetre square, it's a millimetre square. It's not the whole thing that's squared, okay? I'm just saying that because I know some people do get a little bit confuzzled by that. Similarly, this is 100 centimetres. That says 10. So 1 metre squared is equivalent to 10,000 centimetres squared, which is secretly 100 squared centimetres squared. That's the end. And 1 kilometre is 1,000 metres. So 1 kilometre squared is 1 million meters squared, or in other words, 1 kilometre squared is 1,000 squared meters squared. Yes, we're getting the gist of it? So, looking at our new conversion chart, because obviously before it was just millimetres, centimetres, metres, kilometres, no longer are we multiplying, again, if you're going from a small unit to a big unit, you're dividing. No longer are you dividing by 10, 100,000, you're dividing by 10 squared, 100 squared, and 1,000 squared. Okay? Now, lots of people, as I said last lesson, I think, they look at this and I'm teaching and everyone's nodding and saying yes, and as soon as they get to a question, they just forget all of that and just do 10, 100, 1,000. So please, 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 look to see what kind of unit it is. Is it an area unit? Is it just a normal unit? Is it a volume unit? I'm not going to write the actual numbers because they're too big. Yes? Okay. We know what those numbers actually are. Jamie?
Sorry, I think you wrote this above, but it's 1,000, so it's 10 squared, 100 squared, 1,000 squared, but it still has kilometers. Okay.
So yes, it was that number's millimeters squared. Yes.
Yeah.
So these are obviously all multiplied by. Alright, so we've done length, we've done area. Next one is obviously volume. No surprise what we're going to do here. This is 1 cubic centimetre, 1 centimetre cube. So this equivalent to 10 millimetres, 10 millimetres, and 10 millimetres. Okay, so this would be 1,000 millimetres cubed, or in other words, 10 cubed millimetres cubed. Hopefully we're seeing a little pattern here. So we've got 100 centimetres, 100 centimetres, 100 centimetres. So it's 1 million. 6 centimetres cubed. There's the ends. And then this bad boy is obviously 1,000 metres, 1,000 metres, 1,000 metres. Oh, that's a lot of zeros. 2, 3, 4, 5, 6, 7, 8, 9. Okay. And our chart for volume is divided by 10 cubed, divided by 100 cubed, divided by 1,000 cubed. Oh. Multiply by 10 cubed, multiply by 100 cubed, multiply 1,000 cubed. Easy peasy, lemon squeezy. Alright? So check the kind of units you're looking at, and obviously you divide or multiply by those numbers. Excellent. Now, this whole unit conversion is also applied when it comes to similar areas. So we've looked at similar shapes and our lengths, and we know that one length divided by another would give us the same value as another length, its corresponding lengths divided by each other. But when it comes to areas, now if we look at these two rectangles, okay, so we've got 6 units here, we've got 2 units here, we've got 18 and 6. So I can see that shape B is similar to shape A, and it has a scale factor. Okay, remember when we talk about enlargements, we talk about scale factors? So our image length divided by our original. So what would be the scale factor from this rectangle to this one? What if I multiply this rectangle by to get to that one? Remember? 3. Now, oh gosh. You may or may not recall scale factors in enlargements are given the letter K. I don't know why. Sorry. Maybe some history behind it. You're welcome to go and have a look at it. I've never cared. But the scale factor is assigned the letter K. And in this case, that measurement will be 3. But let's have a look at the areas of these shapes. Is it 3 times bigger? So what's the area of this rectangle? I've chosen rectangle because it's nice and straightforward. Sorry, what's the area of triangle? Of rectangle A? 12 units squared. And my area of shape B, Emily, is? What's my area of shape B? Rectangle B. What's a triangle? Area of rectangle B. How do you find the area of rectangle? So what's 6 multiplied by 8? Let's do it ahead. 6 multiplied by 10. And 6 multiplied by 8. Add those together. There you go. 108 units squared. So whilst we can see that the lengths have all been multiplied by 3, we can see that our area has not been multiplied by 3. Yes, you're happy with that? Because 12 multiplied by 3 is not 108. But what is our scale factor for area? How much bigger is it? What is 108 divided by 12? 9. So our scale factor of area is actually 9. At this point, you're all very intelligent young ladies. You should be thinking, oh, why might it be 9? Why might the scale factor for area be 9? Yeah? Exactly, because 3 squared is 9. So if our scale factor for length is a certain value, then if we're talking about the area of those shapes, it would be that value squared. So we can see that the connection is that the area is not multiplied by k, but by, how do I relate it to k? K squared. Oh, awesome. Get that? Yeah. So I know that the area of this shape here is 5 centimeters squared. I know that this length is 2. I need to find this corresponding length. We've been told that they're similar shapes. We haven't, but simply we know they are. So if this area is 80 and this area is 5, that means that we would be able to find the value of k squared. Are you happy with that? So the information they've given us on this diagram is that they've given us the 2 areas. So that's going to allow us to find the area scale factor. In other words, k squared. So k squared would be found by doing 80 divided by 5, because they are our 2 areas. And 80 divided by 5 is 16. So if k squared is 16, what does that mean the value of k would be? Yeah? 4. Easy, easy. Now that's going to allow us to find length x. Because I know that if this length of my small shape was 2 and my scale factor is 4, my value of x is going to be 8. Okay? So depending on the information that the question's given you, you're going to be finding either the scale factor or the area scale factor. And you'll be using that information to find something else. Okay? Last little bit on this pack, similar volumes. So we've talked about the scale factor for length being k, the area is k squared. Oh gosh, what do we think it's going to be for volume? But let's have a look to make sure. So our small shape. Oh, so what's our scale factor for the length k? How do we know what our scale factor for length is, James? Good, because we've got these corresponding lengths, and I know that 6 divided by 3 is 2. Looking at this cuboid, how do we find the volume of the cuboid, Gabrielle? Do you remember? Have a guess. You've got cuboid. Yeah. Yeah, so for a cuboid, you're just multiplying your 3 measurements together. So imagine you're meeting at a vertex. The 3 measurements that meet at that vertex will enable you to find, multiply together will give you the volume of it. The rule for finding volumes of any prism, you're all comfortable that this is a prism? I'm throwing out words now. What is a prism? Do you remember what a prism is?
It's like a
3D shape, yeah.
but when like the face is like another shape.
Yeah. Give me okay, is a pyramid a prism?
Is it like so it's like elongated like that way?
Yeah, so essentially a prism is where you've got there's 2 end faces that are the same shape. And then you've got that carried on all the way through. Yes? So like for example a carrot would not be a prism because it's triangular. So whilst it's circular, or whenever you cut it like that, it's not the same size circle. Whereas a cucumber is more like a prism. It would be more cylindrical because when you cut a cucumber, most of the surface is the same size.
What's a pyramid then?
So a pyramid would be a 3D solid, but it wouldn't be a prism. Okay, so are we all happy with those terminologies? So prism. So this is a prism because I've got this shape front and back. And to find the volume of a prism, you find the area of the end face and then multiply that by the distance between the faces. So we've got here 3 multiplied by 2 multiplied by 1. So that would be 6 centimeters cubed. Well, if I know that my scale factor for length was 2, what does that mean that this measurement here would be, Dinah? Yeah. And this one here, Elena, would be? Pardon? Yep. So the volume of this bad boy, Lily, is what?
I don't know.
Excellent.
48.
Nice help from the sidelines. Okay, so we've got the volume of A is 6, volume of B is 48. So our scale factor is going to be, pardon? 8. And funnily enough, that is K cubed. Excellent. Because our original scale factor for length is 2. And then and we can see our scale factor for volume is 8, and the connection between those numbers is that it's 2 cubed. Okay? So, in summary, for similar figures, scale factor for length is K. For area is K squared, and for volume it's K cubed. Okay? Are you all comfortable with that? Right, I've got a pack of questions for you.